Going over chapter 2.6 here, properties of congruence, starting on page 88, working our way over to page 90 before we get to some of the review of some of the assignments that we're going to be doing.
Mr. Schaub?
All right, so let's review some of these properties of congruence that are talked about in chapter 2.6. The reflective property, basically remember, that means any quantity is equal to itself. Got some examples on the board here of how that can work in terms of the geometric concepts as well as algebra. A is equal to A. Any numeric quantity is equal to itself. Any segment, any angle is equal to itself. Symmetric property, you see that basically. If you have one segment congruent to another, AB is congruent to CD, I can reverse the order of the equality and state that CD is equal to AB. Pretty common sense. Or mathematically, using numbers, some number A times some number B is equal to some number B times some number A. Right? That's called a symmetric property. I think you can see the truth of that. Transitive property of equality. All right? If we have A is equal to B, B is equal to C, then A is equal to C. That might be true of a number, some number values. You may be familiar with doing stuff like this in algebra, solving equations, or do stuff like this. And furthermore, in geometry, if I want to establish the congruence of, let's say, AB is equal to EF, I know AB is congruent to CD and CD is congruent to EF. I can go ahead and state the congruence of AB and EF. You have various of the properties of equality: addition, subtraction, multiplication, division, substitution. Basically, what these are saying algebraically and also geometrically, anything you do on one side of the equation, adding, subtracting, multiplying, dividing, as long as you do the same thing on both sides of the equation, you have not changed the fact that the left is equal to the right. All right? Substitution property basically says this: if A is equal to B, B is equal to C, then you can use A or substitute A for C in any given equation where those qualities are listed. I gave you an example of a typical algebraic equation that you would have done. We did examples of this in our class. X plus 7 is equal to 12. What property of equality says that I can subtract 7 from both sides? The subtraction property of equality. All right. What does that yield? X is equal to 5. Check that. What property of equality am I using when I'm checking to see if my X is equal to 5 is correct? I'm substituting. If X plus 7 is 12, I'm going to substitute 5 for X in my check, and therefore you get 12. Right? Now, furthermore, we had an example 1 on page 89. Well, John is on YouTube forever now.
Okay.
So, if GH is congruent to JK, then JK is congruent to GH. Now, I asked you guys, what example, or what would be the answer? What property of equality would justify us stating this? The symmetric property of equality that I have underlined here.
Whoa.
DE is congruent or equal to DE. Why is that true? What property of equality or congruence says I can make that statement? The reflexive property, right?
Yes. And
If angle P is congruent to angle Q, Q is congruent to R, what justification can I say that Q, therefore, angle Q is congruent to angle R? Or we could also say substitution. You'll find that a lot of times you can use either one of those as reasons for certain statements that you may make. All right? Example 2. You have a diagram of this segment with the points N, P, and Q respectively marked on that statement. We're told that N is the midpoint of MP, P is the midpoint of NQ. Show that MN is equal to PQ. No, I can't, because you can listen to this again. Now, there you go. Point N, we're told, is a midpoint of MP. If it's a midpoint, I can state that MN is congruent to NP, or it's equal to NP, right? That's what midpoints do. They define a middle part of the segment which cuts into 2 equal halves. The same thing, I can state that NP is also equal to NQ because P is that midpoint, cutting that particular part of the segment into 2 pieces. Now, if N is the midpoint of NP, P is the midpoint of NQ, we need to be able to show that MN is equal to PQ. In other words, we need to be able to show that this segment, this part of the segment right here, is going to be congruent to this one here. Now, how do we do that? Well, we can set up a list of reasons to methodically establish the proof that this is good. This is a true statement here. Mn is equal to PQ. We start off with Mn is equal to NP. Why can we say that? Definition of a midpoint. All right? That's our justification for stating that Mn is equal to NP, because we're told in this information, we're given this information that N is a midpoint of NP. So I can state Mn is congruent to NP or equal to NP formally like that. The same thing with NP and PQ. Same reason, definition of a midpoint. All right? Now, I can therefore make the jump and state that Mn is equal to PQ. Now, how can I do that? Transitive property of equality, or you could also say, or did I use substitution? Because we see that Mn is equal to NP, right?
Sure.
Then we come down here, we find NP is equal to PQ, so we're just going to substitute for NP down here, we're going to substitute Mn. That's good. Okay? Now, let's go ahead and keep on going here, all right? Next problem here. Given angle 1 and angle 2. This is the diagram. One of the example problems I believe in the book. Angle 1 and angle 2 are vertical angles. Remember that? We're also told that angle 2 is congruent to angle 3. The little arcs across the vertex of angle 2 and angle 3 indicate their congruence. Now, we also know that by definition, angles 1 and angle 2 are vertical angles, and we know we're told that information, by the way, in the given part of the statement, the information there, but we also know by definition that vertical angles are congruent, right? So do you think that, can you see at least intuitively how that we can show that angle 1 and angle 3 are congruent? You should be able to see that. Now let's go forward from there and methodically state all of the statements and the reasons justifying each statement along the way. Angle 1 congruent to angle 2. How is it we know that angle 1 and angle 2 are congruent? Well, because we know vertical angles are congruent. That's our justification. We're told they're vertical, and we know they're congruent because of that. Angle 2 is congruent to angle 3. Part of our given information. That would be my justification for stating it. And then the final step, stating angle 1 is congruent to angle 3. Again, transitive property of congruence, or you could also state that as the substitution property of equality. Either one of those would work there as a justification for that third and final step. Now, what I've done here is I've taken one of these example problems in the book and I've formatted it in such a way that you're starting to see what one of the major things that we're going to try to accomplish in geometry. We're going to try to establish a way to construct what are called two-column proofs. Proofs are ways that we try to systematically and methodically try to establish the truthfulness of certain statements. Proofs, two-column proofs consist typically of 5 parts. You've got a given statement, like up here, angle 1 and angle 2 are vertical angles, and angle 2 congruent with angle 3. A proved statement, that is to show that these two angles, 1 and 3, are congruent. That would be the second part of this two-column proof situation here. You've got a diagram showing a picture. It's important to have a pictorial representation of what it is that you're dealing with here. That's the third part. The fourth and fifth parts of this two-column proof are the statements and the reasons themselves. All right, so a two-column proof consists of 5 parts. All right, now. Number 19. I did this one for you guys last week, but again, I think we had to dismiss to the background, so I'm not sure how much of this you got down. Check your answers that you got against what I did here. And on problem 19, and what I did, I know we did 1 through 18 on page 91. But let's skip over to page 92 because these page 92 and 93 are really the more important problems. 19 through 26 are the more important ones. I mean, if you can do 19 through 26, I should feel pretty justified and feeling confident that you did 1 through 18 on the previous page pretty well. But you've got this problem here on page 19. The problem reads as follows. It's not exactly drawn up the way you see here on the Smartboard, okay? You don't see it that way. What you see if you look in your book, it says In the diagram, measure of angle 1 plus the measure of angle 2 is equal to 132 degrees. And the measure of angle 2 is 105 degrees. Complete the argument to show that the measure of angle 1 is equal to 27 degrees. Now, the first thing you should do, what I did first of all, is I took the information in the problem and I split it up formally into a given and a proved statement. We're asked to prove that the measure of angle 1 is 27 degrees, and the rest of the information we're told, we'll call that our given information. I copied down the diagram of angle 1 and angle 2 that's in your book. I proceeded from there to formally list the statements from top to bottom to establish the truthfulness, or try to establish whether or not this claim that angle 1 is 27 degrees is true. You should look at this and at least intuitively be able to tell that I can't ascertain what the measure of angle 1 is. And I figure it out to be 27 degrees. Right? Because just stating angle 1 plus angle 2 is 132 degrees doesn't tell me about the measure of each individual angle, nothing about it. But I am given some more information, angle 2 is 105 degrees. So what I do in the process, I can see that angle 1 must be 27 degrees, but to methodically state this, systematically with statements in the reasoning process. Y'all go through these reasoning steps in your head all the time when you work algebraic problems like this. What we're doing is we're trying to create a systematic, formal way of listing all of those steps that you would be going through in your head and giving reasons or justifications for why it is you can say each one. That's what two-column proofs are for. To help you methodically and systematically think about, organize your thoughts to establish the truthfulness of a claim. So, angle 1 plus angle 2, 132 degrees. What is my justification for making statement number 1? It's given, right? Measure of angle 2 is 105 degrees. I should probably put these degree symbols up here. Now, I could have actually compressed step 1 and step 2 into one statement. Just put a comma here after 132 degrees and then stated the measure of angle 2 is 105 degrees. I broke it up into 2 steps, you know, whatever. We'll talk about this more as we go on. Sometimes it's good to set if this was a longer proof, if this was a proof that had like 10 or 12 steps in it, I would probably be looking for ways to compress some of the steps into one, and I might have taken 1 and 2 and just made one sentence across there for the first statement and then just listed given. But I broke it up into 2 statements, and you can see the reasons for statements 1 and 2 were both given. Now, number 3, measure of angle 1 plus 105 degrees is equal to 132 degrees. What is my rationale for stating that? I know. Well, you know, but everybody's just might have stopped. What is my rationale for stating the third statement? It is going to be substitution. What am I substituting though?
Number 105 for angle 2.
That's what we're trying to make sure is clear. Okay? Now, finally, number 4. To state formally that the measure of angle 1 is 27 degrees, what I'm doing here is I have to subtract 105 from both sides, right? So I'm using my subtraction property of the following. And remember, as I work these out, SUBST, I'm using that as a short form for the word substitution, so I don't want you to get that mixed up with SUB period, which I'm using for subtraction. Okay, shorthand version for subtraction. Now we need to continue on, but first of all, let me do this. I'm going to pause this for just a moment. All right, this is problem number 20. Problem number 20, what I did is I took the information in the problem and I set it up as formally as a 2-column proof. I took the information that was given and listed it as given. There was a particular statement, BC, we have to prove that BC is congruent to DF. I listed it formally here as a proved statement. Okay? So I took the problem in the book and I just formally wrote it down here what a 2-column, so that a 2-column proof would see more like what it's going to look like. The diagram here, you have this line BX that is bisecting segments AC and DG. Okay? Now, what we have to do, we're told AB is congruent to FG. AB is congruent to FG. We're told that, right? So we're given that information. Now, we're told that BF, the line right here, bisects AC and DG. We have to prove that BC is congruent to DF.
What are you doing?
All right, so what we've got to do here is, you notice typically the last statement in any two-column proof is the statement that you're looking to prove. BC is congruent to DF. All right? So what we have to do is come up with reasons for each one of the statements. What's the justification, for example, to be able to say that BC is congruent to AB? All right? If I know that I'm told AB is congruent to FG, why is it I can state that AB is congruent to BC?
Because letters.
No. What is my justification? Nope.
Transitive.
You're close. I want something a little more close to the heart of the matter. If you said definition of a midpoint, I would accept that, but I would rather see definition of a bisector. Okay? Definition of a bisector. Bisectors do intersect at the midpoint, but it is a bisector that we do have. Okay? Definition of a bisector. What about AB and FG? Given information, right? So don't burn too many brain cells on that one. Just look up at your given information. If you see a statement written down, you're like, how do you justify that? Look up the given information.
Record.
All right, now, let's go ahead and formally state the reasons for each one of the statements. Okay, let me finish this up. BC is congruent to AB. Why can we say that? Definition of a bisector. Number 2, given. Number 3, the same as number 1. We're stating formally that FG is congruent to DF. That means we're stating this, like, I shouldn't use 2 hash marks, I should have just used 1. But the point here is this. DF.
Substitution.
Not yet. Okay? DF is congruent to FG. Why? Definition of a bisector. Now, why can I now go, what justifies me? What allows me to go ahead and state that BC is congruent to DF? What property of equality? That would be one. What would be the other?
Transitive.
Transitive, yeah. Okay? So I could state either transitive property or substitution. Okay? Either one of those would work. That's my ugly T. Okay? Well, now the wrong color. Okay. Okay, now, your homework is going to be, I didn't get a chance to get the problem in 21. We'll probably look at it tomorrow, maybe 22. I know you still have some other classes that we weren't able to get to. Your homework tonight, I want you to start on page 95, go through page 97. There's 26 problems. I want you to do them all. That's going to be a chapter 2 review. We'll look at it tomorrow. My plans are to give you guys a test Wednesday, possibly Thursday if we don't get far enough into it tomorrow. But just get that done and be ready to ask them any questions that you may need to tomorrow, okay?